Assalamu alaikum. My name is Basit Ismail, and today we are going to learn the topic of functions from the unit 4, and this topic belongs to computer programming with a course code 6900. So what are functions? Functions are basically blocks of code or blocks of code which are also called chunks of code. We write these code, we write functions so that we are able to improve the readability and conciseness of the code. Okay, so function is a block of code that runs only when it is called. So you have to explicitly call it. I will show you how to write a function, how to call or invoke a specific function. You have to call a function and then it runs. Okay, so there are a number of ways a function can be written. A function can have parameters, which has been written over here, or it cannot have parameters. So a function will have parameters will be called a parameterized function, and a function with no parameters or no arguments would be called a non-parameterized function. Non-parameterized. So what is the usage? What is the main functionality which functions give us? They give us code readability, code reusage, and more specifically it gives us the ability to call a specific code whenever it is needed. It does not go sequentially. Okay, so functions are used to perform certain actions. What does it mean? It means that if you have a specific calculation to be done, then functions can be written and function can be called. When functions will be called, then they will perform that specific action. And here it is written. They are important for reusing code. For example, you have written a program to write. For example, you have written a program to add a number of integers, 2 or 3 integers. So if you just write it in without the function, then you have to write it again and again. You have to repeat. You repeat. Otherwise, if you write it in the form of function, you write the code once and then you call the function wherever it is needed, and the function runs, and you have the addition program over there. Okay. So that is how that is what is written here. Define the code once and use it many times. So we can also say that functions are also similar to loops in the way that both are used for repetition. However, the repetition of function is different in the way that loops have a specific value with which they are changing, and however with functions you can give different values. Okay, so the basic template, the simplest form of the template of a function in a C++ language would be like this. You would have void word, and then you would have a function name. This is the function name. Then you would have the parameters, brackets or round brackets you make, or parentheses you may call them. Here we would pass the parameters. Okay. The parameters would go over here. So if we are defining just declaring the variables, then they would be called parameters, just declaration. However, if we are actually giving them values when the function is called, then we call them arguments. And then we have a curly bracket starting, which is defining the opening scope of the function, and then we have the closing bracket, which shows that this is a closing scope. Here the function is going to be started, and here the function is going to end. Start and then end. Okay, and then in between these two brackets we would have all of the code which we need to reuse or repeat. Code to repeat. That's the basic template of a function. Okay, so here we have been given a number of functions. The basic type of function which we have in C++ language and we have seen up until the units till now is the main function. This main function is also called the driver function or engine function. Here is where the execution of the program starts. The program cycle execution starts from the main function. You just have to understand, I just have to remember all of the things that I have said or I have mentioned until now, that the function will have a return type. We just saw a void function. Void means no return. It does not return a value, right? No return of a value. And then here we have int, it means that it is returning an integer. And if you see this specific line of code, we can see that this 0 is an integer and it is returning this 0 integer. Okay. So that's the basic int main function. However, int main function is the function which is required for the basic execution of a program. However, you can write your own functions, or you can call the functions from the standard library. We will discuss most of them in the later slide. Just have to see the basic simple function in the C++, which is my function. We have the return type of void. It does not return anything. The function is not returning anything. The name is my function. The my function word is confusing, so you may change it with simple print or print. Simple print. You may change the name of the function. The name of function once defined is set in stone. However, when you have just declaring the function or you are defining the function, you may use any name of the function. Name can be anything. Name can be anything. However, there is a convention there as well. The convention is to convention. What is the convention? Convention is to name as the functionality is. So whatever the function is doing, for example, the function is adding two integers, then you give the name of add int or add two ints, something like that, so that the person who is calling the function, or the developer who is calling the function, or the programmer himself is calling the function, he remembers that this specific function is used for adding two integers. You use the naming in such a way. The convention is like that. Okay, so we have just a simple function, a void. It is returning void. The name is my function. It does not take any arguments or parameters. It does not have any parameters. And then it is printing a simple cout command with I just got executed. This is an English statement which it is printing. So whenever this function will be called, it will only print this line. From here, you can see that these functions are really powerful tool or technique in programming, because these are powerful because, for example, we had a loop in this function and we wanted to call a loop over something, or we had an array, or we were dealing with a database. So if we would just have to call this specific function, and the functionality written in the scope of the function will all be called without explicitly needing to write it. Okay. So how do we call a function? Here we can see that this function has been defined, and then in the main function we are just writing the name of the function with its appropriate signature, and then the function is being called. We write the function 3 times, my function 3 times, it is being called 3 times. Okay, so there are two basic types of functions, user defined and standard library functions. So we will go over them one by one. The first type of functions, user defined, are those functions which are written by the programmer, as per their need. So if you want to print something and the specific sentence has not been printed in a predefined function, then you write your own function. And similarly, if you want to take the name of the age of a user or a student, you are writing a program for a student and you are taking the name and the age of the age of that specific student, then you write a specific function for that and it can be used. So what does it say? It says that you can also create functions as per your need. So your need will define the functionality of the function. Such functions created by the user are also known as user defined functions. So these specific functions will be called user defined functions. Okay, so the next type of functions are standard library functions. These standard library functions are those functions which are used in C and C++ programming languages, and they come with the compiler. So whenever you write you install the compiler on the computer, these functions are already there. So these functions are usually defined in the header files. For example, cout is a function which is used for printing. Okay, you are familiar with the cout and cin function. Both of these functions belong to the IO stream header file, IO stream, input output stream. Okay, so what does it mean? It means that these functions are already defined. Somebody has already written the signature and the definition of these functions for you, so that you can reuse them. So that is what is written over here. The cout is a standard library function to send formatted output to the screen. So whenever you press 5 and you run your computer, you run your program, then a specific program will run. And on that particular console, if you want to print something, then cout function is used. Okay, so this function is defined as in the IO stream header file. So that is what is I have just explained. Okay, so here we have another program dealing with the standard library functions. I have already discussed IO stream. CMath is used for math functions. all of the math functions are included in this particular header file. I have explained all of these points. Here we are defined two floating points, num and root, and then we are taking input for num, and then we are taking the root for that specific number. For example, a user enters 4. So if we take the square root of 4, we will get the value of 2. So here that is what is being calculated. The most important or the most relevant thing in this particular slide is this function square root, which is being passed an argument num. So this square root functions belongs to this CMath library. So this the signature of the function would be something like this. They have defined it to be float. There is a specific float type of function which has been defined. It might return, it is also returning a float type of a function. So that is how the signature of this particular function would be in the CMath library. So here we are just outputting the root which has been calculated for the specific number. So we are just printing square root of number and for in the specific precision, and here is the value. We would get 2 over here. If we enter the number 9 here, we would get 3. So we just go over the square. We are taking numbers and then we are calculating the square roots of them, and then we are printing them. Okay. So there are different types of user defined functions. If you are writing the functions yourself, then they would either have a return type, they would not have a return type, they would have an argument, or they would not have an argument, and the last type would be with return type and with our argument. So we would go over all of these types one by one. So here we have just basic 2 simplest form of functions, which are returning a value. The first function is returning int, and the second function is returning float. So the name of the first function is get. You can write any type of any name. So if we had a name of get I or get int and get fl for float, that would have been more better. However, you can use same name for the function, but due to having different data types, different return types, the compiler would be able to tell which function is being called. Okay. So here in the first function we are just returning a simple whole number 10, and in the second function we are returning 10.2, which is a floating or decimal point number. Okay, so function without argument and return type. So here we would have functions which do not have an argument, do not have parameters, and do not have any return type, and no return type. They are not returning anything. Okay. So here we are just starting from the normal signature of the C++ program. We have a void main here. You have seen in the previous slides that we had int main. Here we have a void main. Void means the function is not returning anything. And here we have also another similar function which is void print name. We are not inputting any value. There is no value in this specific function which is being taken, and the function is not returning anything. It is just printing this specific sentence, cout hello 1. So whenever this function would be called print name, if you called it in a loop from 0 to 10, then this function would print 10 times depending upon the actual relational operator being used, and then this hello 1 would be printed 10 times. Okay. So here we have a function which has both return type with arguments and with return type. So if we have to write a function which returns a value and also takes some arguments, then we write the signature of that specific function in this way. The function would have, instead of having a void, it would have int and then the name of the function and then the integer, first integer and the second integer, and these are the parameters of the function. Okay, and then we are adding these functions. If you know this signature a plus b, what does it do? It takes the value of 2 specific integers and it adds them. So we are returning here, it will calculate it. If we give the value of 5 and 6, it will calculate them and then return the specific value. Okay. So how is the function called in the C++ language? Call by value in C++. Call by value means that whenever you call the function or invoke the function, you give it specific values, and then the values are used in that specific function for the variables that have been declared for those values, and then the function gives you the output. So in call by value method, the value of the actual parameter, this is what it is saying, and I have just explained that the actual parameters is passed to the formal formal parameters. What are those formal parameters? The function parameters are called formal parameters. The parameters defined in the function signature are called function parameters. We can say that the value of the variable is used in the function call is in the call by value method. So, if you pass the value of suppose you had taken the name from the user, and then you pass this user name to a function which takes a string, then that string would have the value of username, and this string would be called the formal parameter, and the username would be called as the actual parameter. So, this signature would be following the call by value method. Okay. So, in call by value method we cannot modify the value of the actual parameter by the formal parameter. What does it mean? It means that if you are using the actual parameter, then the value, whatever you have stored the value in actual parameter, that value will be passed to the function parameter. So, you are not changing it, you cannot change it, you are using it as it is. In call by value, different memory is allocated for actual and formal parameter. Here it is important. I will explain it in the form of a code. Suppose you had written int x equal to 5 and int y equal to 10, and then you had this function and you had passed x and y. Now, and this parameter would have been a and this parameter would have been y. This parameter, x variable and y variable would have a specific their own memory in the RAM, and a and b would have their own memory. So, these values would be copied, and then they would be passed. So, because these variables would have their own address, this supposedly this address is 32, this is 36, this is 40, and this is 44. So, these variables are not the same. They are not copying the addresses, they are just copying the values. So, that is one of the basic things that you have to understand. Okay. So, the actual parameter in the argument which is used in the function call, whereas the formal parameter is the argument which is used in the function definition. So, that is what you have to understand. The actual parameter would be the parameter which we have defined and which you are passing to the function, and the formal parameter would be the parameter which you have used in the function definition. So, these are two different things. You have to understand this difference between formal parameter and actual parameter. I am highlighting it for showing the difference. Okay. So, here we have been given a program with the call by value in C++. We have a function with no return type, it does not return anything, and then we have with the name change, and here we are defining declaring variable int num, and then we are printing one value. We are just taking an input from the user, and then we are adding 100 to it, and after the addition we are printing that specific number again. If we come to the actual main program where the function of invocation is being occurring, function invocation or function call. So, here in the function call we can see we are using a value. We have declared a variable x to be 100, and then we are printing the value of x. We are just showing the user that the value of x before the function call, what is it? We are using the value of 100, it prints 100 over here, and then we pass that 100 to this specific function. Because we pass this 100 to the specific function, here it comes the value of num would be equal to 100. 100 would be added to 100, num would become 200, and num would print the value of here, the number value will be 200. So, in this specific line 200 would be printed. However, because it is not copying the memory of the parameter, it is just copying the value. Here it would be 100, but again on this line the value would become 100. Here the value would be 200, and here the value would become 100. Why is it so? It is so because we are just passing the value of x into num. We are not copying the address of the x into num. If we had copied the address of x into num, then after the change of 100 to 200, x would become 200. Because we are just passing the value of x into num, then after the changing, the change would only be reflected in the scope of the function. Here only the value is changing, and after the function call, the change has not impacted the actual value of x. So, 100 would be printed again. This is the difference which you have to understand between call by value, how the call by value in C++ works. Okay, so the last topic related to this unit is recursive functions. Recursive functions are those functions which call a copy of itself in the function body. Functions calling a simpler copy of itself in its body. Okay. So, formally what does it say? Recursion is a process which comes into existence when a function calls a copy of itself to work on a smaller problem. So, you have been given a problem, a function has been passed a specific problem to be solved, and then you divide that problem into smaller copies, divide the problem, and then those smaller problems are passed to the function copy, and it does it recursively. It does it in this way. The function 1 would call itself, and if you are calling it function 2, then the function 2 would call itself, and if function 3 would solve a specific part of the problem, function 2 would solve the other specific part of the problem, function 1 would solve the all of the remaining problems. So, any function which calls itself is called a recursive function. So, you have to understand this this is a basic definition. Calling itself, a function which calls itself in any other with any logic is called a recursive function, and such functions calls are called recursive calls. So, if a function is calling itself, then it is a recursive function, and those calls are called recursive calls. However, it is important to impose a termination condition of recursion. Why is it important? This is important because the recursive functions, if we do not have a terminating condition, if we do not have a no terminating condition, then what would happen? The function would keep on calling the copies of itself, and the computer or the compiler would go on a loop and it would get stuck. So, it must have terminating condition. Okay. So, recursion cannot be applied to all the problems, but it is most useful for the tasks that can be defined in terms of similar subtasks. So, this is important. All of the programming problems or all of the problems related to programming cannot be solved with the form of recursive functions. All programs cannot be written recursively. You have to understand very cleverly where you can use recursion, which you cannot use recursion. It has given you some examples. Recursion may be applied to sorting. Sorting, what does it mean? Sorting means you have a list of numbers 1, 3, 5 and 0, and you have to sort which numbers comes first and which comes next. So, you divide the this list into 2 parts, and then you sort this part, and then you sort this part, and after the sorting of these parts you sort them again, and then this process would continue, and at the end you would have a sorted list. So, this sorting can be done in the form of recursion. Searching, what is searching? You are searching, you have a list and you are searching of a specific value in the list. So, you divide the list again, and then you search the value in one half of the list and then the other half of the list, and then you get your answer. Or traversal problems, you have to move from what do we do? Sometimes we define nodes of a network in linked lists, and in those linked lists we have to traverse between the nodes of the network, and when we are traversing between the nodes of the network we may use recursive function. So, enough with the theory, let us just go on our code example. So, we have one rather simple recursive function. Here we have a recursive function which returns you an integer value, and the name of the recursive function is display. We are passing a number n to it, and if the n is equal to 0, then the terminating, and we have given a terminating condition. However, if the n is not equal to 0, what are we going to do? We are going to again call the function itself with the value n minus 1. For example, we started from 5. It will come over here, it will check if n is equal to 0. Is 5 equal to 0? No, 5 is not equal to 0. So, this block of code will not run. It will go to the else portion. Here it would just print 5, and then on the next line or statement, it would come and it would check 5 minus 1 equal to 4. Okay, fine. So, it will pass 4 to it, and then on the next run of the program, it would again come and check 4 is not equal to 0. Yes, 4 is not equal to 0. It would come in the else part 4 minus 1 free. And then same for the 2 for 1. When we come to 1, it would print it and then go and check over there 1 minus 1 equal to 0. If 0 is equal to 0, the condition would become true, and then it would just return 0 and the function execution would terminate. So, you have to understand the one of the important things related to which we had just discussed in this previous slide, that However, it is important to impose a terminating condition. For example, in this particular slide, if we did not have, or this particular function, if it did not have a terminating condition, what would happen? The 1 would become 0, and then 0 would become -1, and then -2, and so on. Because numbers do not end, the number line goes on forever. So would have been the execution of this program. So it would have been keep on printing signed integers with the negative values. So that's it for today's unit on functions from the course code 6900 on computer programming. My name is Basit Ismail. I hope you were able to understand it. Thank you. Allah Hafiz.